So welcome back again to another video. In this video we are going to talk about the basicity of amines. Okay, now I am going to focus this video for these three molecules. We have primary amines, tertiary amines and secondary amines. Officially you may know that the basicity order of amines are like this. The primary amines has the least basicity, and then we have the tertiary amines, then we have the secondary amines. Now let's look at like how we can position these guys like 1 2 3. Okay, here I have put the reaction of this basicity, like you know what the basicity means. I guess basicity means like the ability to attract a proton. So when we're talking about the basicity of this particular molecule, we are talking about the ability to this molecule for attracting a proton. So now if I write the products for this particular reaction, we have it like here we have the nitrogen, and here we have the attached hydrogen and the two hydrogens here, and we have R group here. This is the primary amine. And also there is a positive charge forming in the center of our molecule. And likewise I'm going to draw the two structures here. Here we have the attached hydrogen and R group and another R group. Positive charge here. This is the secondary amine. And finally we have the tertiary amine here. Okay, now when you look at the basicity, right, basicity, this is the reaction which is associated with this basicity. Now if I am about to say that this molecule has higher basicity, this molecule has lower basicity, likewise, okay, I need to look at this reaction. Okay, so if you look at this product, okay, if you look at this product, if you can say this product is much more stabilized, what it means is this reaction is much more feasible. If this product is much more stabilized, then this reaction is much more feasible. What it means, this particular molecule, right, this particular molecule is more attracted to this proton. In other words, this has higher basicity. So what you mainly have to do is look at this product, look at the product and determine what is the most stabilized product, and that particular product forms with the reaction with more feasible one. So that particular molecule has higher basicity. So when you look at these molecules, you will see the pattern like this. So let me take this color like this. So this has the lowest stability, then this, and finally the tertiary one. Why? Because you know this R groups has effect of this pushing electron density towards your positive center. Now when you push electron density towards this positive center, this positive charge is going to be diminished at certain point. So you can stabilize this compound. Here you have two parts to stabilize the compound. Here you have three parts. So according to this stabilization, okay, according to this stabilization, you will see that tertiary amine is much more stabilized, which means this reaction is much more feasible. Or in other words, this particular molecule, this tertiary amine, okay, so this is not an amine, right? This is not amine. So this tertiary amine should have the highest basicity, but it's not. You can see the tertiary amine is on the second place. Why is this? It's because of the steric hindrance. Right? This is the special case. Like we cannot straightly determine the basicity based on this stability. Okay. Now in most cases we are determining the basicity based on this particular stability. Okay. But in this case the steric hindrance comes into the place. Why is that? You will see that this tertiary amine has big R groups, right? This big R groups is there. But here when it comes to secondary amines, this hydrogens are very small. That this hydrogen's electron cloud is very small. So now when you have a component here, when it comes to the attachment with your particular nitrogen, these guys will block it because of the steric hindrance. So that's why this reaction, this particular reaction, even though this is much more stabilized, the proton is really it's not unlike, like it's really hard to come and bind to this nitrogen because of this steric hindrance. Even though this is stabilized, this hydrogen couldn't find a better route to come into this nitrogen. So these R groups will be blocked. R groups are going to block it. That's why we are going to put our tertiary amines into the second place. Okay, now this is our this is the first place, second place, and third place. This has the lowest basicity, and this is the highest basicity. So highest basicity is this way. And finally, I need to take you through the reaction coordinate and energy diagrams. Okay, so here we have the reaction coordinates, and here we have the energy. Now, if we take two amines, secondary amines and tertiary amines, this graph would be like this. Let's take, here we have the secondary amine. Okay, here we have the secondary amine. Now let's take a product like this. This is the product. Okay, this is the product. Here we have the reaction coordinate, and now also let's take like this place. So like the energy values can be changed, right? I have not looked into the exact values of the secondary amines energy and the tertiary amine energy. I just wanted to tell you one specific point for this tertiary amine. Okay, here now let's take a product like product in this place. Okay, now if I take the two values here, okay, here we have the E1 and this guy here, this is E2. Okay, E2. So always E2 is bigger than the E1. Okay, E2 is bigger than the E1. Sorry, E2 is bigger than the E1. Why is that? It's because of that steric hindrance, right? So actually, that I have told you in this case, this tertiary amine, this reaction is not feasible relative to the secondary amines because of this steric hindrance. So due to this steric hindrance, the potential of this particular molecule will be increased. So the activation barrier increases with this steric hindrance, right? So with the tertiary amines, you may see a higher activation energy than the secondary amines basicity reaction. Okay, so that's why I have drawn this particular diagram. So actually in this case, the product should be changed, right? So here this has to come down. You know that this is the tertiary product now. So based on the product, this product's energy, you know, this has lower energy because this is stabilized, right? This is stabilized. So this has to come in up than here. So like even though this changes, this activation barrier is higher in this tertiary one because of the steric hindrance. That's the point. So if your exam paper asks for the explanation, there should be that word, the steric hindrance should be there. That's a very important point. So I hope you got some amount of idea for it. This is a very important point when it comes to amine. So I hope you get it right. If you have any questions, feel free to comment below.